right, let's talk about absolute value equation. But first, what is absolute value? The absolute value of a number is basically how far it is from zero on the number line. The distance is always positive. Okay, so we write it as two vertical bars, like square root of x here. Here. Okay. So the definition of absolute value of a real number x, written absolute value of x, is defined by absolute value of x. It's gonna be itself if x is positive, so we don't do anything. It's gonna be negative x if x is negative, right? So inside the two vertical bars, x can be positive or negative, right? But if you put a vertical bar in it, it's gonna become positive. Does that make sense? Okay. So if the number inside is positive or zero, we just keep it as is. And if the number inside is negative, we flip its sign to make it positive. Okay. All right. So here, let's take a look at 1A. I want us to evaluate absolute value of -3. Well, it's going to be, because inside the negative, we're going to drop that negative and turn it into positive, because absolute value is distance. Distance cannot be negative. Absolute value of -2 minus 4. First, we're going to simplify inside the absolute value first. So it'll be -6 here, which is 6. Okay. And absolute value of 2 to the -1. Well, 2 to the -1, let's rewrite this. That's not a negative number, right? That's just saying that's 1/2. And 1/2 is already positive, so we just leave it as is. So the final answer will be just 1/2. Now let's solve some equation involving absolute value. I have absolute value of x equals 7. That means x can be 7 or -7, right? Because, so that means my solution is x either -7 or x equals 7. Right? Because if you want to check it, you can check it. You can check it. So you plug in -7 absolute value, it is 7, right? And absolute value of 7 is 7. So both are checked, right? But I'm not gonna do the check from now on, okay? Part B, absolute value of -x equal 2. On the left hand side, I can write like this. This is -1 times x, right? And absolute value of -1 times x, and can split it apart like this. Absolute value of -1 times absolute value of x. Well, absolute value of -1 is 1. And absolute value of x is, well, let's leave it absolute value of x. Well, we don't write the 1 there, are we? We just put it absolute value of x, right? So absolute value of -x is x, which is equal to 2. And now this equation means either x can be -2 or x is 2. That bracket means or. Okay. In this case, box my solution. Right, same thing here. X minus 5, it can be -9, or x minus 5 can be +9. Right, whatever inside the absolute value can be +9 or -9. And then let's solve. For the first one, if we add 5 both sides, we can always add 5 both sides, add 5 both sides, add 5 both sides, add 5 both sides. Go down a little bit. So x equal -9 plus 5 is -4, or x equal -14. I'm sorry, +14. +14. And that will be my solution. Yeah, and you can check on your own. Okay. What do you think? Absolute value, part D, absolute value of x plus 2 equal -7. First of all, is it possible? Remember, the left-hand side is the distance. It represents distance, right? Can distance be negative? No, right? So we say no solution. Whatever x value you plug in it is going to be positive, right? You can plug in a -1,000,000 and -1,000,000 for x plus 2, and it'll come out positive after the absolute value, right? So it's always going to be at least 0. It can't be negative, right? So you say no solution. Right? There's no x that can satisfy this equation, so no solution. You can write no solution, or you can do that notation in an empty set. Okay. Actually, I want to show you something before I move on. In 2a, remember we did absolute value of x equals 7. Let's see the solution here. There you go. Your answer will be -7, x equal -7 there, and x equal +7, right? And then 2b, there you go, -2 or 2, right? Let's do x plus 2, absolute value of x plus 2 equals -7. X plus 2 equal -7. Nothing. Right? There's no solution here. There's nothing there. Not 9, no, nothing there. Right? I mean, no solution. All right, let's talk about some absolute value inequalities, about properties of the absolute value inequalities. If I have absolute value of x less than d, then the value of x is going to be sandwiched between -d and +d. So d is just a number, some number, right? And then the same case is true with the, if you include the equal in it, it's the same thing. It'll be x will be sandwiched between -d and d. Include here, they include the two values, -d and d, right? As opposed here, they don't include -d or d. Right? If absolute value of x is greater than a distant number, subdistance, then it's going to be a two-tail. So it's going to be, so here, let me make it a little bit longer. Let me draw it here. So here, let me draw it out for you. Right. So here, x is going to be between -d and d. And it's going to be hollow, because I don't include it. I'm going to highlight that part. I mean, that's a solution. That's your solution. Move it up a little bit. Well, this one, I'll keep up with my color here. Still -d, +d. But this time, these two values are included as part of the solution. Okay. And for x, absolute value of x is greater than d, then the solution is going to be on the two-tail. Instead of in the middle, it's going to be a two-tail. So like this. -d, +d, and the solution is, and again, it's hollow because there's no equal side there. The solution is going to be either x is less than -d, like that, or x is greater than d. See that? And with the equals, then you have to make it solid dot. That's all. Okay. I can show you with the decimal thing here. Right here is x is less than d. So you can see, let me make the distance, see if it's smaller than, there you go. There you go. It's just going to be sandwiched between the two. Notice that when d is negative, nothing. Nothing. It makes sense, right? It cannot be negative. X is the distance. It cannot be negative. There's no solution. That's why you see nothing. So anything less than 0, it doesn't make any sense. Right? There's no area there to shade. Right? Where x is, let me mute that. When absolute value of x is greater than some distance, I didn't know a here. There you go. It's two tails. As you can see, it's two tails, right? And it's, of course, when a is negative, it doesn't. When a is negative, absolute value is saying that is absolute value of x is greater than some negative number. Is it true? Yes, it's true, right? Because on the left side, it's going always positive, right? And positive number is always greater than a negative number. So when you see negative a, you see everything is shaded because it's true. Right? It's true. A distance always greater than a negative number. No, one more time. Okay. All right. Stop share. Go back to our lecture. All right, let's solve this. Here, 3a, I have absolute value of x plus 7 less than 3. So here is one of these less than thing right here. Right, so precisely it's going to be the first case here. Right? It's going to be sandwiched between the two. So I have x plus 7 like that, greater than negative 3 and less than 3. Right, so we have three sides here. And the same, we're trying to solve for x. So what we're going to do is we're going to isolate x, right? So the next thing we're going to do is subtract 7. Three sides, not just both sides, right? It's going to be three sides. Here, that's cancel. Negative 3, negative 7, negative 10. And then just x in the middle, less than negative 4. Right, so your solution is x is between negative 10 and negative 4. Okay, infinity, positive infinity. Here is negative 10, negative 4. You don't have to put a 0, it's fine. The 0 somewhere over here, maybe. You can put the 0 there. Right, so your solution is between those, and we don't include them, so it's going to be a hollow circle. Okay. And your interval notation is going to be negative 10, parenthesis, because I don't include negative 10, 2, so comma mean 2, negative 4, and that will be your solution. Part B, this is going to be the fourth case, right? It's going to be on the two-tail, so that means 3x minus 8 over 2 less than or equal to negative 4, or 3x minus 8 over 2 greater or equal to negative 4. And then you solve this inequality. You know how to solve these. Multiply both sides by 2. I like to say 2 over 1, just to distinguish the top and the bottom. So on the left side, the 2 and the 2 cancel. It's just 3x minus 8 less than or equal to negative 8. Negative 8. And then we saw add 8 both sides and do that, right? Add 8 both sides like that. And then somehow those cancel at both sides. So we have 3x less than or equal to 0. Divide both sides by 3. 0 divided by 3 is 0. So x is less than or equal to 0. Let's see on the other one. See. The same thing, right? You multiply both sides by 2. Oops. 2 over 1. Let's just say 2 over 1. So I have 3x minus 8 equal to negative 8. Add 8 both sides. 3x equal to 0. X equal to 0. Oh, I'm sorry. It's I'm sorry. That's not negative. Greater or equal to 4. What did I say before? It should both be positive 4. So add 8 both sides. This is when things turn differently. So 0 on the left and then 16 on the right. Divide both sides by 3. 16 over 3. More like it. Okay. So the solution is this. Let me try to draw it here. Zero here, and then 16 over 3 here, and they're gonna be solid, right? Because I'm including the 0 and the 16 over 3. Okay. X is less than 0, equal to 0, so it's gonna be everything from the left of 0 to the left of 0, and greater equal to 16 over 3, so to the right of that. See that? The two-tail. Okay. So interval notation, you're gonna write like this: negative infinity, because this is negative infinity, positive infinity, right? Up to 0, union, that big U means union, 16, oh, you know what, bracket, very easy to forget, 16 over 3. And not infinity. It's a slightly more complicated solution for the greater part. I want you to think about C and D and tell me what you think. Right. Try it yourself. I think I just did it, but try it yourself, okay? It's supposed to be critical thinking. You're not supposed to solve it. Please don't solve it. All right, good luck.